Hello everyone, welcome to Code and Learn. In this GoLang lesson 47, we will be covering the topic of interfaces. So let's get started. So what exactly are interfaces? Interfaces are types that define the functionality of a type. They specify what the type should do, but not how it should do it. I have mentioned this before, but it's worth mentioning again. Abstract types such as interfaces only specify functionality, whereas concrete types like struct with methods specify both functionality and implementation. To write an interface, we use the type and the interface keyword, and inside the interface, we declare the signature of methods for that interface. The methods declared inside the interface are known as method set of interface. To implement an interface, a type must implement all the methods that are defined in it. As long as the type implements the methods specified in the interface, it is considered to implement the interface. In Go's general lib, interfaces named typically end with er, such as io.writer. This is a convention widely used in Go community. Here are a few examples of creating interfaces. Here we say type, shape, interface, and inside it, we define the method. In the first interface shape, we have a method called area, which returns a float. Next, we have an interface car, which has two methods. The first is start and the other one is stop, returning a bool. So that's essentially how you create interfaces in Go. Now, let's look at few examples of how interfaces are created and implemented with code. First, let us create our interface. I'm going to create a shape interface which has an area method. Type shape interface, and then inside here the method that the interface has, area, which is a method that returns the area in float 64. So that's exactly how you write an interface. Type, the name of the interface, interface keyword, and then all the methods that the interface has. Interfaces in Go are implicit, unlike other languages where you have to specify if your type is implementing an interface in the type declaration. In Go, you don't have to do that. For example, in Java, you say class X implements interface Y. A type is considered to be implementing the interface as long as it has implemented all the methods declared in the interface. The type can have additional methods that are not declared in the interface, and it will still meet the requirements of the interface. Please note that a type can implement multiple interfaces that has different set of methods as long as all those methods are implemented by the type. Now let us expand on our previous example. Now let's create a rectangle structure to implement this interface. Here I have created a rectangle structure with fields width and height. To implement the interface shape, it has to have a method area. So let's create a method area on rectangle. Here we have created the area method with the same signature as that of interface. This essentially means our rectangle structure is implementing the shape interface. I'm going to create another type structure which also implements the shape interface. We have created circle type with radius, which is a float 64. To implement the shape interface, we need to create an area method on the circle. So let's create one. Here we have created the area method which returns a float 64, matching the signature of area method inside the shape interface. Now, let us see how interfaces work. First, I'm going to create an instance of rectangle and circle. Rectangle has a width of 5, height of 3, while circle has a radius of 4. Now I'm going to create a shape slice which has elements of type shape, which is our interface, and then add both rectangle and circle. Since both the rectangle and circle satisfy the interface shape by implementing the area method, we can use both inside the shape slice. Let's now range over shapes to print the area. Here what I'm doing is I'm ranging through shapes and then printing the area. Since shape is an interface type which has a method on area, I can expect to call area on any shape inside the loop. Let us run our program to verify the same. Go run main.go, and as you can see, the area is indeed printed from both circle and rectangle. That is basically how you implement an interface. You can also change this functionality to say func print area, which accepts an interface shape. And then let's just copy this to print the area. Here we are printing the area of the shape. We can do this since shape is an interface that has a method area. So instead of doing this, we can also do print area shape, and this will work as it worked before. Now, if I create another type, square, and say width float 64, initialize a square, and then try to print the area from the square. We cannot do this because square is not implementing the method inside the interface. But if we implement the method as square area which returns float 64, you can see the error has now gone away. If we run our program now, you will see it works as expected. Area of square was printed. Another thing I mentioned was it does not matter if the struct or the type has other methods along with the area. As long as it has the area method, it will keep on meeting the shape interface. So I can say print area, which is a function that prints the area of a square, and then I can do print area past the square. Even though I have created print area method on the square, it still meets the interface as long as the area method is implemented. If I comment it out, you will see Go will complain again. How are interfaces used in Go? Interfaces are very useful in coding because they allow you to focus on the functionality instead of the implementation details. Since interfaces are implicit in Go, they make it easy to add or remove functionality, making it real easy to refactor your code. For example, consider a database interface. Your application requires storage, but you don't care about which database is used. You create a database interface that declares the method required by your application, such as finding or deleting a record. Then you can code around the interface. If you start with a memory store when you are developing your application, you can later switch to Postgres or any DB of your liking, as your dependent code doesn't care how the methods are implemented as long as they are implemented. This means that if you want to change how things are done tomorrow, it will be easy for you to do so. So, interfaces provide the flexibility to do that. You can also use embedding while creating interfaces. Let's look at an example of the same. First, we have the shape interface with area method. Then we create a colored shape interface, embedding shape, and then adding another method, color, which gives out a string. Let us look at embedding interfaces with an example now. Here I can create another interface type object, which is an interface, has a method name which gives the name of the object, and I can embed the shape interface in here. Let's now remove everything from here. Now I create func print object which takes O of type object, returning nothing, and just printing fmt printf area and then the name. And we can do object.area object.name. Now if we create a rectangle variable, rectangle, which is a rectangle of width 5 and height 10. If we pass it to print object, it won't work since object now has a name method along with the area method, which has been promoted from shape to object because of embedding. So I'm just going to copy this method and then return a string, say it's a name, and then return rectangle. As both the area and name methods have been implemented from the object interface, it's no longer complaining. If you run the program now, it should work as expected. As you can see, the area and name were printed. In Go, it's usually recommended that interfaces have small number of methods, maybe 4 or 5. That's where embedding comes into play. You can create a larger interface by embedding smaller interfaces, while also keeping your code concise and precise. In Go programming language, an empty interface is a type of interface that doesn't have a specific type or value assigned to it. With the introduction of Go generics in Go 1.18, a pre-declared identifier any was introduced as an alias for an empty interface. The empty interface is used when the type of value is not known, but it's necessary to specify that the value can be of any type. Since Go is a statically typed language, an empty interface is used to declare values that can accept any type of data. So, an example of this would be reading a JSON document where the values could be of any type. In the next lesson, we will cover type assertion, which allows us to convert an empty interface value to a value with a type. That's it for the lesson. Let's now summarize everything we have learned in this lesson. First, we went over how interfaces are abstract types which only specify the functionality and not how the functionality is implemented. It leads to a very maintainable code. We also saw that interfaces are implicit. By defining a method, a type meets an interface. You don't have to explicitly say that your type is implementing an interface. It will meet the interface as long as the type has implemented the method. That's it for this lesson. Please feel free to ask any questions you may have by posting a comment under the video or reaching out to the Discord server. I hope you enjoyed it. Until next time, happy coding.